Hello everyone. Today we are going to talk about the machine learning evaluation matrix under AI 101 fundamental series. Here we will discuss about the different metrics deployed for the classification, regression, and the object detection and segmentation problem. And you can see in the table there are different metrics for the classification. For example, the accuracy, confusion matrix, precision recall, F1 score, AUC score, logarithmic loss. Similarly, for the regression, we have the different evaluation metrics like mean absolute error, mean square error, mean root mean square error, and R square error. And another is the R square, not the error, but just the R square. Okay. Um, Here, for the object detection, we have the different evaluations like average precision, mean average precision, intersection over Urian, pixel accuracy for the segmentation problem, especially. Let's discuss more about these evaluation matrix. Now let's start from the confusion matrix, and this is a matrix for the classification problem. And here we have one confusion matrix. Here we have six classes, and our model is going to predict the predictions on the test data. This is the prediction result made by our model. And here in the y-axis we have the truth level for each sample of this data set. And here the diagonal elements are the truly or correctly classified sample by our model on this test data, and the non-diagonal elements are the confused samples by our model. For example, in this exciting class, all these values are predicted by the model as exciting, but some value, for example, the two samples here are actually the fear sample, but the model treated them as a exciting, right? This is the two samples are misclassified, and similarly the five samples are actually the neutral class sample, but the model predict them as a exciting. Similarly for the other. And so if we add all these diagonal elements and divided by the total number of the sample, this is the accuracy, right? Here you can see the formula. These are the all the diagonal elements are the true positive plus true negative. That's why these are the correctly classified classes, and divided by total sample for each classes here, right? Here we have the 50 classes, 50 sample on each test classes. So we have the total sample is 300 sample, and these are the some correctly classified elements which are shown on the diagonal. And so we add all the diagonal elements and divided by 300. This is our accuracy, right? So let's discuss more about the precision recall by one example here. This is one example where the two samples are the model is going to classify. One is the blue dots, which are the vocal music, and the cross orange sample these are the non-vocal musics, right? So after training, our model make a prediction. This is our classification boundary, and inside this boundary all the samples are treated as the vocal, and outside this boundary are treated as the non-vocal, right? So what is the true positive here? The true positive are the samples which are actually the model treated or model recognized as the vocal, and these are in fact these are also the vocals, right? For example, these are the samples, and only excluding three samples in this classification or in this region, right? All the samples are the true positive samples, and these three samples are the false positive samples, right? Because false positive means the model treated these samples as a vocal, but actually these are the non-vocal samples, right? Similarly, the negative, false negative. False negative means these two samples you can see outside this classification boundary region. These are the model treated as the negative samples, like the non-vocal sample, but actually these are the positive sample or the vocal samples. That's why these are the false negative sample, and and these all these sample which is denoted by the cross orange sign. These are actually the true positive sample. These are the non-vocal sample, and also model predict them as a non-vocal. That's why these are the true negative samples, right? Now you can understand what is the true positive, what is the false positive, what is false negative, and what is true negative, right? And now the accuracy is the true positive plus true negative divided by true negative plus true positive plus false positive plus false negative, right? Total. And here we have the 8 sample is correctly classified as a vocal here. These are the true positive sample, and the 7 sample here are the true negative samples, and that's why these are the true negative, and we add them as a correctly classified samples divided by all the sample, and our accuracy is around 0.75. Okay, now the precision is true positive divided by true positive plus false positive, and here we have the true positive sample 8, and 3 is the false negative false positive sample. That's why we have the accuracy around 0.72 here. Precision, this is the precision. Okay, and for the recall you can see the true positive divided by true positive plus false positive, and the recall rate around 0.8. Sometime we have even we have the high precision, we got the very low recall rate, right? That's why for example, if we have the small classification boundary like this, and then we can get the all the samples are vocal, right? Here all the sample are vocal. If we make this boundary only include the 3 sample, all the samples are the vocals, right? And then our precision may be true positive divided by true positive plus false positive is around 100, right? 1. Okay, because we don't have the false positive here in this case. Okay, that's why the precision is 1, but the recall is, if you can understand, outside of this all the samples are the non-vocal, and that's why the recall could be the very low, right? So we need another measure. We call it as F1 score, and which is a harmonic mean of precision and the recall, right? And because we need to make the balance on the precision and recall, that's why the F1 score is another strong evaluation matrix like the accuracy here. Okay, we calculate the accuracy like this, 2 times of precision into recalls divided by percent per recall, as you can see in this formula. And not only the f1, but we can make the f beta score f2, f3, f5 like this, and by adding this coefficient, beta coefficient, like this one. Okay. Now another metric is the ROC AUC score, and this is a curve of the plot to identify the correlation between the true positive rate and the false positive rate, right? And if the curve is cover the whole area, then the AUC score is very high, and we can say the model is performing very well. And the area under this curve is called the ROC AUC score. And if the area is more, then we can say that the model is performing well. Okay. Another metric for the another metrics are for the regression, and for the regression we have the four metric mean square error. This is the difference between the actual value and the predicted value, and we make the square of this difference. Okay. If we have this n number of sample, we collectively collect all the sample and make the square of difference. Okay. And another is the mean absolute error. Mean absolute error, instead of making this square, we take the absolute difference between the predicted and the ground truth. Okay. And in the root mean square, we make the log difference between the predicted and the actual the ground truth. Okay. And the ROC R square measure is another evaluation matrix which measure the impact of the independent variable and the dependent variable. Okay. And if the R square is equal to 1, indicate that a model is perfectly explain all the variable in the dependent variable, and it is an excellent fit of the data. You can say that the independent variable and the dependent variable are highly correlated, right? And the formula is 1 minus SSR, means sum of square residual divided by sum of total sum of squares. Okay, sum of square total, one difference. This is the R measure, R square measure. Now in the object detection we have the different evaluation metrics, and one of them is IOU, intersection over union. The intersection over union is, you can say here, this is the blue rectangle or the bounding box is the actual ground truth, and the red one is the predicted by the model, and this the area is the intersection area is the blue area here, and this is the union area, and this is the IOU, intersection over union, right? And and according to this intersection over union, we can you can compute the true positive value based on the threshold. We set some threshold. If we set the 0.5 is equal to the 0.5 is the threshold for the IOU, and above that threshold, we all the sample, all the detection or all the detection made by the model, we term as the true positive, and other prediction below that threshold we treated as a false positive. Okay. And the false negative is a ground truth and not detected by the object. Okay. And there is no true negative value. Actually the true negative is the ground truth, and we only make the detection on object of the interest, and also out of this all the backgrounds are the are we treated as the negative. True negative is not considered in the object detection. Okay. Now another is the precision and recall, and we can see here the formula: true positive divided by true positive plus false positive. True positive recall is the true positive divided by true positive plus false negative. And we already discussed, we have the threshold here 0.5, and we have the IOU is equal to 0.8 in this case, and that's why we treated this detection as the true positive. And another detection, we have the IOU is equal to 0.1, and we have threshold is equal to 0.5. That's why we denoted this detection as a false negative. Okay. And in this way, maybe we have the large number of the precision and the recall, and this is a call to make a correlation between the recall and the precision, and the precision and recall curve is somewhat this, and the area is gradually decreasing, and we in the average precision we take such 11 areas. Okay, this is one area, two area, three area, and similarly it is going to decrease, and we take the 11 such sample and make the average that we call the average precision. And similarly, if we have the n number of classes, then we make the mean of all the average precision. We call it as a mean average precision. Okay. For the semantic segmentation, similarly as the object detection, here is one example. This is the ground truth, and our model predict the segmented area. This as our object of interest made by our model as a prediction. Okay, and the intersection could be this one, and union could be this one. Okay. And the union intersection over union we call as a IOU. Okay, and the dice is the two times of intersection of A and B divided by absolute of A plus absolute of B, and the dice of F1 score is the harmonic mean of this precision and recall. Okay. This is the end of presentation for the evaluation matrix of machine learning evaluation matrix, and we will discuss more about the machine learning technique and the next slide. Okay, thank you very much.